In this video, we're going to take a look at the angle associated with the gradient of a curve at a point. Now, if we look at the diagram here, we see that at the point P, we've drawn a tangent to the curve, which is there in green, and the gradient of the tangent is the rise over run. And so we've effectively got a right angle triangle there, and I've called the angle in there tan theta. Now that angle there would be the same as the angle which the tangent makes with the x-axis, because those two tangles are corresponding angles, since the x-axis is parallel to the run. Now, using trigonometry within the triangle, tan theta is equal to the opposite over the adjacent side, which is rise over run. So therefore, if the gradient's rise over run, then it follows then that the gradient m is also equal to the tan of the angle that the tangent makes with the x-axis. Now we can see then if the gradient is equal to 1, you'd have tan theta equal to 1, which means that this is an angle of 45 degrees. And if the angle is -1, so in other words, we've got a line going this way, the angle that it makes with the positive x-axis then would be 135 degrees. So just to illustrate that, the first example here, we've got an angle of 45 degrees, so that straight line there has a gradient of 1. This one over here has a gradient of -1. And so therefore, there's the angle of 135 degrees. So it's taken from the positive x direction around to the tangent line. So let's have a look at some examples here. So let's just pull the shade up for the moment. We want to find the coordinates of the points on the curve with equation x squared minus 8x plus 13. Where the tangent makes angles of 45, 135, and it's parallel to this line. Okay, so if it's 45 degrees, as we just saw in the previous slide, that means that we're talking about a gradient of 1. So we want to know when the gradient function is equal to 1. So if we find the gradient function, the y dx of this is going to be 2x minus 8. So we then put that equal to 1, which we solve, gives us 9 on 2. So therefore, when we substitute 9 on 2 into the equation to find the actual coordinates of the point, we get 11 over 4, negative 11 over 4. So the coordinates of the point then are 9 over 2 and negative 11 over 4. So at that particular point on the curve, it has a gradient of 1. Now the second one here asks, okay, what's the point where the gradient is, or the gradient of the tangent makes an angle of 35 degrees with the positive x-axis. So this time we've got 135 degrees, so that means the gradient in question is -1. So we find the x value for which that occurs at. In this case, that's going to give us 7 over 2, which when we substitute gives us then negative 11 over 4. So this one is 7 over 2 and negative 11 over 4. And then the final question asks whereabouts is the tangent parallel to this line. So if we transpose this equation, so it's now in the form of mx plus c, we can see that the gradient of the line has a value of 4. So we want to know then, when does the derivative function equal to 4? So you can see that when we solve that equation, it gives us x equal to 6. Substituting means therefore that at the point 6, 1, at the tangent at that point is going to be parallel to this particular line. In other words, it will have a gradient of 4. In our last example here, it says a golfer hits a ball according to this equation. So x is the horizontal distance travel and h represents the height of the ball. Now you can see from the equation being quadratic, which tells us then that the path of the ball, of its flight, is parabolic in now my line here is not quite parabolic, but it'll serve the purpose. So we want to know at what point, and of course the tangent tells you the instant at which the ball, tells you at that instant the direction of the ball. So we want to find at what point this tangent makes an angle of 45 degrees with the horizontal. And then over here then, I want to find the angle at which it then makes it an angle of 135 degrees, so it'll have a negative gradient there. And this one says when the ball is travelling parallel to the ground. So that would mean at a certain instant it would be travelling horizontal, which means that that would be at the top of its flight because it's travelling upwards here, momentarily horizontal, then it's going to start to head down towards the ground. So we need to know the derivative, so we take the derivative, which is 25 minus 2x. So in the first case, we want to find out when is that equal to 45 degrees, and of course tan of 45 is 1. So solving that equal to 1 gives us 251 over 2. When is it 135 degrees? So in this case then it's negative 1, so it's 251 over 2. So in the first instance, for an angle of 45 is at the point 249 over 2, and when it's negative 1, it's 251 over 2. So both points are very close together. So it's very close to the top of the path, and of course it's travelling horizontally when the gradient's 0, which is at 125. We haven't got any units there, so it could be meters. So all 3 points are very close. And finally it says, what's the direction of the ball's path when it's 100, when it's at a distance of 100 from where it was initially struck? So we put into our equation, we substitute the value of 100, which gives us 50. So we know that the gradient's equal to the tan of the angle. So with solving tan theta equal to 50 gives us 88.9 degrees. So essentially the ball has been struck and it basically goes straight up and down. So I've just redrawn the path. So it's basically a shot like that. So it's gone very high, won't travel much distance. And at that point, it's 100 meters from where it's been hit and an angle of 88.9 degrees. So you should now be able to finish off exercise 19C, in particular the questions 8 and 11 to 13.